In this lesson, we'll look at properties of parallel lines. We'll check to see pairs of angles that are congruent and supplementary. We'll look at proving theorems about parallel lines and solving real-life problems. Our angle pairs that we learned in the last section each have a description about whether they are congruent or supplementary. Let's add some other angle pairs besides these four pairs of angles, which are vertical angles. Those are congruent, and a linear pair. Don't forget about using these, which are supplementary. Our other ones corresponding are congruent, alternate interior are congruent, alternate exterior are congruent angles, and consecutive interior are supplementary angles. Let's look at a few examples. The measures of 3 of the numbered angles are 75 degrees. Identify the angle and explain how we know. So that would be angle 2, those are vertical angles, congruent. Measure of angle 6 is 75 degrees. Those are alternate interior angles, congruent. And angle 7 and those would be corresponding angles, congruent. Next, we'll learn to find the value of x. There's several ways we can identify if the measure of this angle is equal to 120 or if it's supplementary with 120 degrees. So first we'll identify that the angle with the angle that's 120 that I've just marked are vertical angles. Now these two angles are consecutive interior. First identify what they are, and that'll tell you how to set up the problem. Consecutive interior angles are supplementary. Supplementary means the total equals 180. So we're going to set 2x plus the 120 equal to 180. Subtract 120 from both sides. So 2x has to equal 60 degrees. Divide by 2. X has to equal 30. In our next example, we're finding the value of y this time. So same idea. We're going to identify angle pairs that we're familiar with in the problem. These two angles are already an angle pair we can identify. If not, look for vertical angles or linear pairs with the angle. These are alternate exterior angles. We know alternate exterior angles are congruent. If they're congruent, that means we set the two things equal to each other. I'm going to then solve my two-step algebra equation, add 3 to both sides, and then divide by 6. So y equals 22. Our next example, we're going to show alternate interior angles, or prove it that they are congruent. without using corresponding angles in the problem. So we're going to be given, we're going to start with the drawing and use an example. So P and Q, transversal line T. I'm going to use some angles in my drawing to help me. So given P is parallel to Q, we're going to prove that angle 1 is congruent to angle 2. So we'll start with our given information. P is parallel to Q, and that's given. We're going to we're proving alternate interior angles congruent, so I'm going to pick some other angle pairs to work with. So I'm going to label all the angles. And it doesn't want me to use corresponding angles, so I'm going to work with some other angle pairs. So I'm going to have angle 1, we know is supplementary to angle 4. And those are by linear pair postulate. We know angle 2 is supplementary to angle 3. Same reason, linear pair postulate. You can either use congruence or supplementary in your proofs depending on what they ask for in the problem. So we know angle 4 is congruent to angle 3, and that's our alternate exterior angles theorem. So then our proof statement, angle 1 is congruent to angle 2, and that's by our congruent supplements theorem, which says if two angles are supplementary to the same angle, they have to be congruent to each other. Our last example, a balloonist sees a car at a 37-degree angle of depression from a horizontal. In the diagram, measure of angle 1 is 37 degrees. What is the measure of angle 2 and how do you know? So the measure of angle 1 is 37 degrees. We've defined the measure of angle 2. Well, angle 1, and here are my parallel lines. Angle 1 and 2 are alternate interior angles. Alternate interior angles are congruent, so measure of angle 2 is also 37 degrees. Is their alternate interior angles congruent? And that's all for our lesson today.